Now this is the question from triangles that too picked up from the exemplar. Now let us see this question right now. In the given below figure, OB is the perpendicular bisector of the line segment DE. FA is perpendicular to OB and FE intersects OB at C. FE intersect OB at C. Prove that 1 by OB, 1 by OA plus 1 by OB is equal to 2 by OC. Now let us see what is given in this. Okay, we will write from the beginning part. OB is the perpendicular bisector of the line segment DE. So OB is perpendicular to DE. So when OB is perpendicular to DE, so by the figure you can see here that I can write the word that angle OBD is equal to angle OBE is equal to 90 degrees. This is first word. Next, similarly, FA is perpendicular to OB. So according to the figure, you can check it out. FA is perpendicular to OB. It is given for you. So FA is perpendicular to OB. The meaning of this is angle FAO is equal to angle FAB is equal to 90 degrees. Right? So this is the part which is given for us. So what I have to prove here, and one more point is also given for you. FE intersects OB at C. Okay. Just you write and mention here FE intersect OB at C. Fine. Now RTP, what I have to prove? I have to show that 1 by OA plus 1 by OB is equal to 2 by OC. This is what you have to prove. This is RTP. Now let us see the proof part for this. Now I will consider first set of triangles, okay, which are open on the left side, which are in the direction of the left. So I'll take it in triangles AOF and triangle BOD. I'll consider these two triangles. Okay, AOF and triangle BOD. In this case, if you check it out, these two triangles clearly, angle AOF is equal to angle BOD. That means O is the common angle in this, right? Right? So angle O is the common part, common angle in this. Next one, okay, you mentioned this part, common angle. This is the one done. And angle FAO is equal to angle DBO is equal to 90 degrees. Right now I got two angles as equal. So according to AA similarity, by AA similarity, what I can write now? I can write as triangle AOF similar to triangle BOD. If the two triangles are similar, the ratios of their sides are equal. So according to this, what I can write? I can write as OA by OB is equal to FA by DB, right? OA by OB is equal to FA by DB is equal to OF by OD, right? From these three, just I will consider this part as OA by OB. I will consider these two only is equal to FA by DB. This is one thing I got from the above. So let's name this as equation 1. Right. Now in the similar way, we will consider second type of triangles. Right. The second case is in from triangles or in triangle FAC and triangle EBC. Okay. Here is the case FAC and EBC. These two triangles, you will check it out right now here. Okay. The next part. So when you see this one, in triangle FAC and the next triangle is EBC. In this case, angle FCA, right, is equal to angle ECB. This part FCA and ECB. These two are equal because of vertically opposite angles, right? So this is the case, you got it. And as we already discussed, FAC and EBC, these two are 90 degrees according to the given part. So angle FAC AC is equal to angle EBC, right, equal to 90 degrees. This is already known. According to AA similarity again. So this is also according to AA similarity. What can you write? Triangle FAC similar to triangle EBC, right? FAC similar to triangle EBC. So from here, what can I write here? The ratios of the sides are equal. So I will write it as FA by EB is equal to AC by BC is equal to FC by EC, right? So I will take only the consideration part of, I will consider only FA by EB is equal to AC by BC. Now this is our second equation. Okay. Now from 1 and 2, let us check it out. What is our first equation and second equation? So we know our first equation was OA by OB is equal to FA by DB. Okay. Now here second equation, if you check it out here, FA by EB is equal to AC by BC. Now one important point. We have, according to the given condition, that OB is the perpendicular bisector of DE. So perpendicular bisector, since OB is the perpendicular bisector, so that means it will make an angle of 90 degrees, as well as it divides the part DE, that is, divides the line segment or the line DE into two parts, two equal parts. Okay, OB is the perpendicular bisector of DE. So that means I can write here as DB is equal to BE, right? So DB is equal to BE. Now what I will do, exactly in the place of this EB, I will substitute this one. So what I will get in the place of EB, if I substitute DB, I will get it as FA by DB is equal to AC by BC, right? Now this becomes our third equation, right? This becomes our third equation. Now if you check, what was our first equation? OA by OB is equal to FA by DB. And second equation, of course, the third equation, FA by DB is equal to AC by BC. So what I will write here, from equation 1 and 3. Okay, so equation 1 and 3. We'll go through this one. Our third equation is FA by DB is equal to AC by BC. And what was our first equation? OA by OB is equal to FA by DB. So from 1 and 3, FA by DB is common, right? Here you can see FA by DB and here FA by DB, but it's common. When those two are common, then of course you can equate OA by OB to AC by BC, right? So therefore from 1 and 3, what can I write? AC by BC is equal to OA by OB. Okay, or else in the reverse way also you can write it, no problem. OA by OB is equal to AC by BC, or AC by BC is equal to OA by OB. So I hope you got up to here, the clear part of up to here. Now the next condition is, what you will do, check it out from this. AC, this is AC. So from the figure, AC, I can write it as OC minus OA, right? This complete OC, from this if I remove this OA, I'll get AC. So AC is equal to OC minus OA. Similarly, BC, I can write it as, how can I write this BC as? OB minus OC. From this complete OB, if I remove this OC, I will get as BC. Exactly these two values I will substitute here. Now what does our equation becomes? When I substitute this AC as OC minus OA here, and instead of BC, I will substitute as OB minus OC. So I will get it as OC minus OA by OB minus OC is equal to OA by OB, right? Now I'll just go with cross multiplication. This will multiply here, this will multiply here. So I'll be left with OB into OC minus OA is equal to OA into OB minus OC. I'll just open the brackets. I'll get it as OB into OC minus OB into OA is equal to OA into OB minus OA into OC. Next, now what I'll do is, OB into OC and OA into OC I'll bring to one side, and OB into OA I'll bring to the other side. So what happens here when I bring this to this side? What I'll do is OA into OC I'll bring to the left LHS part, and this minus OB into OA I'll take to the RHS. So what I'll get now? OB into OC, and this left hand side, this right hand side, what I have, this OA into OC will come to the left. So it becomes plus OA into OC is equal to OA into OB is already there on the right side, and this minus OB into OA will go to the right side. So becomes plus OA into OB, right? OB into OA or OA into OB doesn't make any difference. So out of these two, I can take out OC common. I'll be left with OB plus OA or OA plus OB anyway, right? Here I'll be left with 2 into OA into, sorry, here I'll be left with 2 into OA into OB. Fine. 2 into OA into OB. This is the part what I got up to here. Now, one of the important part is, when I got up to here, I'll write this statement once again. OC into OA plus OB is equal to 2 into OA into OB. This is what I got. Now I will divide both sides by OA into OB into OC. Divide both sides by OA into OB into OC. So what I will get now? OC into OA plus OB by OA into OB into OC is equal to 2 into OA into OB by OA into OB into OC. Okay, OB, OA and OA, OB gets cancelled, and here OC and OC gets cancelled. Now what I'll do, I'll split this denominator for both these terms. So I'll get it as OA by OA into OB plus OB by OA into OB is equal to 2 by OC. Here you can see OA gets cancelled, OB gets cancelled. And what I am left with? 1 by OB plus 1 by OA is equal to 2 by OC. Or else 1 by OA plus 1 by OB is equal to 2 by OC. This is what you have to prove, right? Hence, proved. So for the next question, we'll meet once again. Thank you.